All right, guys, we are on day 2 of 2.5, proving statements about segments. Our goal today is going to be write reasons for steps in a proof. Remember, we are using 2-column proofs, and a 2-column proof is always set up the same way with, of course, 2 columns. And then on the left-hand side is labeled your statements, and the right-hand side is labeled your reasons. So these are called 2-column proofs. There are other types of proofs, but we will not get into that just yet. We're just going to look at the 2-column proofs because they're the simplest to use. Okay, so let's go ahead and get started. Before we do example 1, let's look at some review from the last section. So remember, we have just introduced the theorem of properties of segment congruence. With this theorem, theorems have to be proven. You cannot have a theorem that isn't proven, okay? So we use postulates, we use other rules, and we can use already proven theorems in order to prove a new theorem, okay? So this is the first one we're looking at here. Properties of segment congruence, and we talked about that. For any segment, the line segment AB is congruent to the line segment AB. That's our reflexive property. It's like looking in a mirror. So when you look in the mirror, what looks back? You do. So when AB looks in the mirror, it mirrors itself, so we get AB on the other side. The symmetric property, on the other hand, says that if AB is congruent to the line segment CD, then we can flip it and also say that the line segment CD is congruent to the line segment AB. And we're going to use the transitive property a lot today. If AB is congruent to CD and the line segment CD is congruent to EF, then we can conclude that AB is congruent to EF. Okay, so we're going to look at that. The other thing I want us to see is from section 4 is our properties of equality. So these are very similar to the properties of segment congruence. The only difference is segment congruence, we're talking about segments, so you'll see the line above each length. But under properties of equality, we're just talking about the lengths. So it's the same concept. Instead of using line segments, we're using the lengths. Now remember, when we are comparing lengths and we have AB equals CD, this is talking about a length. This is a measurement. On the other hand, if we have a line segment AB, we use the symbol congruency to compare the two. And this is a line segment where we use congruency. Okay, so that's the important part between those two. And we can use our postulates, the properties of equality, in order to prove our segment congruence. And that's what we did yesterday. Okay, so let's go ahead and look at this. This is from the very beginning, so it's coming back to haunt us now because we're going to need it for our homework tonight. Do not forget all of your properties: addition property, subtraction property, multiplication, and division. So when we're actually solving an algebraic equation, we have to use these properties here. Okay, so these are the 4 that we're really going to use today. All right, so that was a quick review of the postulates and the theorem that we learned yesterday. And now we are going to move into example 2. So let's go ahead and look at example 2. It says, use the diagram and the given information to complete the missing steps and reasons in the proof. Okay, so remember, I will always give you how many steps are in each proof. And in some of them, they already give you some of the information. So what I want you to do is rewrite the information that they give you, and we're going to fill in what is missing. So if we look here, what is given? Well, under A, or the first statement, we're going to write what is given. The length LK equals 5. Well, they give us a diagram of a triangle, a J, K, and L. And they say that the side LK here is 5. So we can also label that diagram as 5. So go ahead and draw the diagram in your notes, and then label the side LK with a 5. And our reason is given, which they already wrote under reasons. Second reason here is also given, and they tell us that JK equals 5 as well. Okay, so JK equals 5. So also on the diagram that you've drawn, go ahead and write a 5 and label it a 5. So we can deduce that JK and LK are congruent to one another because the lengths are the same, okay? So that's essentially what they want us to prove, is that LK is congruent with JL. So they don't give us JL, we're missing that information, but we want to know what property do we use to prove that JL is the same or congruent with LK. Okay, so number 3, they give us a lot of information here. So LK equals JK. Well, we know that because LK equals 5 and so does JK. It also equals 5. And so in order to do that, we're going to use this transitive property. And I want to explain why we use the transitive property here, okay? So basically, the transitive property says that if A equals B and B equals C, then we can deduce that A equals C. Well, the same goes for this. If LK equals 5, and JK equals 5, then we can say that LK equals JK. And that's where we get this next statement, that the lengths are equal, LK equals JK, using the transitive property. And in this case, of equality. And the reason it's of equality is because we're not looking at line segments and congruency. We're looking at lengths. And then to transition from 3 to 4, we can say that if the lengths are equal, then we know that the line segments are congruent. And that's going to be used as our definition of congruent segments. Because anytime the lengths are equal, the line segments are also congruent. Okay? Now, number 5, they have given us a third piece of information, and that is also going to be given. So we will see that we don't have to write our givens all at the top as we progress through the proof. Okay, so the third given information is going to be that the line segment JK is congruent to the line segment JL. And then our sixth and final reason tells us that the transitive property of congruence is used. So I'm going to write that in. The transitive property of congruence is used. And now we can say that LK, the line segment LK, is congruent to the line segment JL. And the reason we can say the transitive property here is used, and using congruency and not equality, because we're looking at congruent line segments and not just lengths. So we can say that if the line segment JK is congruent to the line segment JL, and the line segment LK is congruent to the line segment JK, then we know that LK is congruent to JL. Okay, so that's where we get the JL here in our missing, our final piece of information, which we can label that 5. So all sides of the triangle are congruent using the transitive property of congruence. Okay, we are going to skip the third example, and we're going to look at page 105, number 8. It's going to help you do your homework tonight. So I want us to look at that. I don't have it drawn here, but if you open your book, you can see it. So number 8, and I'm going to write it. The given information is line segment AB is congruent to line segment BC, and the line segment CD is congruent to the line segment BC. Okay, so they give us that, and then they draw a diagram here. So I'm going to redraw this diagram. And we've seen these line segments before, A, B, C, and D. So they draw the diagram, and then they label it where the line segment AB is not just a number, but now it is an algebraic expression, okay? So we have a variable here. AB is going to be 2x plus 1, and then CD is 4x minus 11, okay? They want us to solve for the variable. So solve for the variable here. We are looking for x. But we're going to look for it using a proof and using the reasons that we've just talked about, okay? So we're kind of combining all of section 4 and all of section 5 together in this one problem. All right, so the first step we always take is going to be drawing our two columns. You're going to label the left column statements. And you're going to label the right column reasons. Okay. Now the first step here is going to be what is given. Well, they give us two pieces of information and they're related to each other. So we're going to write it on the same line where AB, line segment AB, is congruent to line segment BC. And then line segment CD is congruent to line segment BC. Okay. So our first step is going to be using this little piece of information that's missing. So we know what this length is and we know what this length is, but how are we going to relate both of those to this middle length, BC? Okay, so that's what we want to figure out. Well, if we know that AB is congruent to BC and BC is congruent to CD, then we can deduce that AB is congruent to CD. Now, what property would that be? Well, if this is true and this is true, then this must be true. So we're going to use the transitive property here. And in this case, it's going to be the transitive property of segment congruence. And the reason it's of segment congruence and not of equality is because we are talking about line segments and not just lengths, okay? Now, once we get the line segments are congruent, we can use the definition of segment congruence. And say that if the line segments are congruent, then the lengths must be equal. Okay, so now we know that the length AB equals the length CD. Okay, so if those equal each other, we will substitute the given information. So this 2x plus 1, we know here that AB, the length AB equals 2x plus 1, and the length CD equals 4x minus 11. So because AB equals CD, we can equate them to each other, and we can substitute the information that we're given in for each length. So on number 4, AB equals 2x plus 1. So instead of writing AB, we're substituting it for 2x plus 1 equals CD, which instead of writing CD, we're going to substitute 4x minus 11. And we are using the substitution property of equality. So with the substitution property of equality, we are now at an algebraic proof, and we just need to solve for x here. So in order to solve for x, we need to use the algebra skills and the properties that we have seen earlier. So what is going to be our first step? Well, our first step is always to move the x's to the left side. So we're going to move our 4x to this side. In order to do that, we have to subtract 4x from both sides. So if we subtract 4x from the right, minus 4x here, we're going to minus 4x here. We get negative 2x plus 1 equals negative 1. And our reason is going to be the subtraction property of equality. Subtraction property of equality. Then number 6, our sixth step, is going to be adding 1 subtracting 1 to both sides. So these will cancel. It leaves us with negative 2x equals negative 2. And that is going to be, in order to move from here to here, we used also the subtraction property. So we're just rewriting that property. And then the final step, number 7, how do we finally solve for x? Well, we're going to use division. We're dividing by negative 2. So negative 2 divided by negative 2 is 1, leaves us with x equals negative 2 divided by negative 2, which is positive 1. So our final step, number 7, is going to be the division property of equality. And the reason we know to stop here is because we have solved for the variable, which is what they've asked us for, and x equals 1. Okay, so this is going to help you do your homework. I will give you the number of steps for each one. I will go ahead and write it under the assignments in OnCourse, so look out for that. It's going to be out of the textbook on page 105. Okay.